Good evening, students. Today I am here with a new lecture and a very important lecture. That lecture is on the equilibrium of a particle or equilibrium of a system. So this topic belongs to the laws of motion chapter number 5 in CRT. So topic is like equilibrium of a particle or equilibrium of a system. So I'm just writing like equilibrium of a particle. So first we have to understood that what is the meaning of equilibrium of particle. For example, any system or any particle is said to be in equilibrium when the net external forces acting on that particle are equal to 0. आप किसी भी पार्टिकल को इक्विलिब्रियम में तब कहेंगे जब उसके ऊपर लगने वाले एक्सटर्नल फोर्सेस का जो टोटल है वो नेट एक्सटर्नल फोर्सेस जो है वो 0 के बराबर आपके पास आ जाते हैं. फॉर एग्जांपल आई एम जस्ट टेकिंग एन एग्जांपल ऑफ forces whenever we have a particle here and two forces are acting on this particle, like F1 and F2 are acting on this particle, and I can tell when this particle is in equilibrium, when force F1 acts on it, when force F2 also acts on it. As this particle is in equilibrium if and only that your F1 is equal to F2 in magnitude and both act in the opposite directions. Like this is a vector quantity, but both should be act in the opposite directions. Then we can say that this particle is in equilibrium. So when forces of same magnitude and opposite directions act on a particle, then you can say that this particle is in equilibrium. So this is the condition for a particle in equilibrium when two forces act on this particle. So condition is that F1 plus F2 equal to 0. For a particle to be in equilibrium, when two forces act on it, this should be satisfied. Okay, this is the case for when you have two forces involved. Now if we have three forces involved, what can be the case? This is very simple. Like we have another force F3 acting on this particle. What is the condition for particle to be in equilibrium? Very simple. It is F1 plus F2 plus F3 is equal to 0. If all these forces are equal to 0, then you can say that this particle is in equilibrium. And in vector sense, it looks like that. For a three particle, it looks like that. For a two particle, two forces, it looks like that. That one is F1 and other is F2. They both are acting on this particle. Now this particle is in equilibrium because F1 is equal to F2 in magnitude. But now if three forces are acting on this particle, what type of situation you have here? One is like this is a particle, one force is acting F1 here, like F2 is acting like here, and F3 is acting like here. F1, F2 and F3, these are the three forces that are acting on this particle, and we have to say that this particle is in equilibrium. अब ये कैसे हम इसको कहेंगे? Like the resultant of F1 F2 is in this direction. Resultant of F1 and F2 is in this direction, and this resultant, when this resultant is equal in magnitude and it is clearly visible here that this resultant is opposite in the direction of F3, then you can say that this particle is also in equilibrium. Like this is F1, this is F2, this is acting in this direction, F2 is getting in this direction, acting in this direction, F3 is acting in this direction. All three forces are acting on this particle. But here, what is the resultant of F1 and F2? This is the resultant of F1 and F2. Let us consider that this is R, and if this R is equal to that F3, these both are in the opposite direction, so we can say that this particle is in equilibrium. Similar question has been asked in JEE Mains exam in some previous years. Like they show the picture like this is F1 and F2. This type of picture they show that, and they ask that is this system is in equilibrium. So you have to say that yes, this system is in equilibrium because net external forces are acting on that is 0. Similar type of question has been asked. और एक बात और इम्पॉर्टेंट है, अगर किसी पॉइंट पे एक साथ बहुत सारे फोर्सेस एक्ट कर रहे हैं, these forces are called as the concurrent forces. These forces are called as the concurrent forces. So now we did a problem. We solved a problem that is based on this equilibrium concept, and this problem is from the Ncert exercise 5.6, example 5.6, Ncert chapter number 5. So this is the problem. Here we have a thread that is 1 meter long and 1 meter from here. 2 meter long thread and a mass is suspended here, 6 kg mass. So what is the weight? 60 Newton. I take the G is equal to 10. So now they did that. They applied the force at point P. This figure has been given in your books. They applied the force here in this direction equal to 50 Newton. And now they asked what is the angle, this theta angle. ये theta angle आपसे उन्होंने पूछा है वर्टिकल के साथ, ये थीटा का वैल्यू क्या होगा. और ये कहा गया है क्वेश्चन में कि दिस सिस्टम इज इन द इक्विलिब्रियम. सो वी यूज दैट कंडीशन एंड देन सॉल्व द क्वेश्चन. लाइक फर्स्ट वी ड्रॉ द फ्री बॉडी डायग्राम ऑफ दैट वेट that is acting in the downward direction. 60 न्यूटन इस मास का, 6 किलो का मास है, इसका वेट 60 न्यूटन नीचे लग रहा है और इस मास को हम अपना बॉडी कंसीडर कर रहे हैं तो इसका फ्री बॉडी डायग्राम बना रहे हैं. तो टेंशन नाउ इज एक्टिंग इन द दिस डायरेक्शन फॉर दिस वेट. सो दिस इज द वैल्यू ऑफ टेंशन. इसको यहाँ पर T2 नाम फिगर में दे के रखा है. सो क्लियरली इफ दिस सिस्टम इज एन इक्विलिब्रियम वी कैन राइट T2 is equal to 60 न्यूटन. वी कैन राइट दैट T2 is equal to 60 न्यूटन. ये हमारा फर्स्ट पार्ट हो गया. ओके, नाउ लेट अस कम टू द पॉइंट P. अब हम पॉइंट P की तरफ देखेंगे. लेट अस ड्रॉ दिस पॉइंट P हियर. दिस इज 50 न्यूटन. दिस इज टेंशन T1 एंड दिस इज वेयर इट इज अटैच. सो आपसे ये थीटा पूछा गया है और टेंशन T2 जो है कुछ यहाँ पर एक्ट कर रहा है जो हमने निकाल दिया है 60 न्यूटन के बराबर. नाउ this body is in this system is in the equilibrium, so we consider that point. We consider right equation about this point. So what is the equation? Like we saw that here tension is acting and this is a theta angle, so we have to resolve the tension T1. This is known as the T1 cos theta and this component is known as the T1 sin theta. Okay, so 50 न्यूटन के एग्जैक्ट अपोजिट में कौन सा फोर्स लग रहा है? T1 sin थीटा. और सिस्टम किसमें है? इक्विलिब्रियम में दिया गया है क्वेश्चन में. तो हम लिखेंगे T1 sin थीटा इज इक्वल टू 50 और T2 के सामने कौन है ऊपर की तरफ को? ये है T1 cos थीटा जो कि हम लिखेंगे T2 के बराबर, जो कि हमने निकाला है 60 न्यूटन के बराबर. वी हैव टू इक्वेशंस 1 and 2. वी सॉल्व दिस इक्वेशंस. डिवाइड इक्वेशन नंबर 1/2. ये दोनों आपस में कट जाएंगे, जीरो भी कट जाएंगे. साइन थीटा अपॉन कॉस थीटा इज टेन थीटा 5/6. सो ये कब 5/6 होगा? व्हेन योर थीटा इज अप्रॉक्सीमेटली इक्वल टू 40 डिग्री और इट इज इक्वल टू 40 डिग्री. सो दिस थीटा शुड बी 40 डिग्री एंड नाउ दिस सिस्टम इज इन द इक्विलिब्रियम. सो व्हेन दिस सिस्टम इज द इक्विलिब्रियम, यहाँ पर जो एंगल बनेगा वो 40 डिग्री का एंगल बन जाएगा. सो वी यूज द कॉन्सेप्ट ऑफ इक्विलिब्रियम ऑफ अ पार्टिकल और इक्विलिब्रियम ऑफ अ सिस्टम व्हेन नेट एक्सटर्नल फोर्सेस एक्टिंग ऑन द सिस्टम इज इक्वल टू 0. सो उसका यूज करके हमने पहले इस वेट का फ्री बॉडी डायग्राम बनाया, वहां से T2 को निकाला एंड देन हमने पॉइंट P पे गए. पॉइंट P पे टेंशन को रिजॉल्व किया उसके अलग अलग कंपोनेंट्स में. लाइक दिस इज नॉट एक्टिंग इन द वन डायरेक्शन, सो वी हैव टू रिजॉल्व दिस. वन इज T1 cos theta, other one is T1 sin theta. So after resolving this, we have T1 sin theta exactly opposite to 50 Newton. We write the equation and then our T1 cos theta is exactly opposite to the tension T2 that has been acting on the point P with respect to that weight. Okay, so this is T1 sin theta 50, T1 cos theta 60. We solve the equation, we get the tan theta is equal to 5/6. So theta is 40 degrees. So this is the answer for this question. I hope you understood the concept of equilibrium of a particle. So in brief, I just want to say that any system is in the equilibrium when net force is acting on that system or particle is equal to 0. I hope you understand the concept. Thank you very much.